Good afternoon, students. Welcome back once again to the mathematics class. So, in yesterday's class, we have studied geometric progression and its properties and some of n elements of a geometric progression, right? So, now today we will solve some problems based on geometric progression, right? So, the first question of the today's lecture, example 1, find the 15th term. Find the 15th term of the GP 1 by 4, 1 by 2, 1, 2 dash dash dash, right? So the solution here question is find the 15th term of the geometric progression. The geometric progression means here it's a sequence a1, a2, so on, an is called a geometric progression if the ratio of any term and its previous term is always constant, right? So here write down the solution given here. First, given 1 by 4, 1 by 2, 1, 2 dash 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 are in GP, right? So now the first term is here. First term A, which is equals to 1 by 4, and next the common ratio R equals to what? 2 here. If you take the ratio between any term and its previous term, always constant, that is here. If you take a ratio between 1 by 4 and 1 by 2, 1 by 2 and 1 and 1 and 2, the common difference is here 2, right? So now the nth term formula is Tn, which is equals to a r to the power of n minus 1, right? So therefore T15, n value is here, we have to find 15th term here. T15 is 1 by 4, a value is first term, that is, and r value is common value, that is 2, common ratio, to the power n is 1 by 4 minus 1, n value is here, 15 minus 1 is 14 it is, right? So T15 1 upon 4, 2 to the power of 14, right? So which is equals to, or which implies T15, which is equals to, in the base it is 2 square, right? So in the numerator we can take it is 2 to the power of 14, in the denominator we can take 2 square, right? So which is equals to this 2 and here 2, get cancel, means what we get finally, 2 to the power of 12, right? It is nothing but the required solution. The 15th term is 2 to the power 12, right? So next question is this question number 2. It is example 2. Find nth term of, find nth term of the GP, nth term of the GP 27 9 3 1 dash dash dash. Solution. Here the given GP is and then in solution part once again given, it is given is 27 9 3 1 dash dash dash. So in the given GP, the given GP, A value is, that is first term, A equals to 27, it is right. Value of A is 27 and R is 1 by 3, it is right. Value of R is 1 by 3. Ratio of any term and its previous term. You can check it out, right? How you check this one? That is A2 by A1 in general. The GP is GP is in general. I'm writing here, right? A1, A2, A3, so on dash AN is there. The GP, how can we get here? A2 by A1, A3 by A2 is equals to so on. Finally, what we get, which is equals to R, right? So here, the value is 27, 9, 3, 1 dash dash dash. So A2 value is 9 by 27 and 3 by 9, like this 1 by 3, which is equals to dash dash dash. What we get here? 3 ones are 9 ones are 9 threes are 3 ones are 3 threes. So it is equals to what? Which is equals to 1 by 3. So the value of R is what here? 1 by 3 is nothing but our common difference between any term and its previous term, that is ratio. So now we have A value and R value, that is first term and the common difference. So now therefore Tn equals to A into R to the power n minus 1, which is equals to, again here we have to find nth term, right? So Tn, which is as it is, A value is 27, R value is 1 by 3 to the power n minus 1, right? So 27 can be written as 3 cube, right? Into 3 to the power of, we can write it as 1 minus n. If we take it reciprocal, then what we can write it here? 3 to the power n minus 1 is there, so here we can write 1 minus n. If 1 by 3, if you write it in reciprocal form, it becomes 3 inverse, that is 3 to the power of minus 1. If you multiply minus 1 inside, n minus 1 means what we get? 1 minus n. Therefore the final value is Tn, which is equals to, when bases are same, power should be added. So the value of Tn is 3 to the power of 3 plus 1 is 4 minus of n, right? It is nothing but our nth term of the given GP. So next question, question number 3. Third example of this lecture. Find the n term of the series. Find the nth term of the series 2 into 2, 3 into 4, 4 into 8, 5 into 16 dash dash dash, right? So here we have to find nth term of the series is there here. Series in the sense sum of the sequences, right? So solution, the first factor of the series are, here two factors are there. Write down the first factor. So the first factors of the series are, 2, 3, 4, 5, 6, so on dash dash, whose nth term is, whose nth term is n plus 1, right? Just go on increasing one term, it becomes n plus 1. And the second factor of the series, second factor of the series are 2, 4, 8, 16 dash dash dash, which form a GP which form a GP here with A equals to 2 and R is equals to 2, and whose nth term is, A into R to the power n minus 1, right? So substitute the value. A is 2, R is 2, 2 to the power of n minus 1. What we get here? Nothing is there, means here 1 plus 1 minus 1 get cancelled. 2 to the power of 1 plus n minus plus 1 minus 1 get cancelled, which is equals to 2 to the power of n we get, right here. So now the nth term of the series. So therefore the nth term of the series is Tn, which is equals to, first factor nth term is n plus 1, the second term nth factor is 2 to the power of n. Therefore the nth term is here n plus 1 into 2 to the power of n, right? Got it? So the fourth example of this lecture, it is example 4. If A comma B comma C, if A comma B comma C are in GP, show that 1 upon A square, 1 upon B square, 1 upon C square are in GP, right? So the solution, here the given A comma B comma C are in GP, so which implies A square, B square, C square are in GP, again which implies 1 upon A square, 1 upon B square, 1 upon C square also are in GP, because there is a common ratio between any two terms. Got it? Which is nothing but our required solution. So next example, fifth example, it is example 5. If A comma B comma C are in GP, then prove that A square plus B square comma AB plus BC, B square plus C square are also in GP, right? So the solution is, write down the given ABC are in GP, right? So here A comma B comma C are in GP, which implies A square, B square, C square are also in GP, right? So now, which implies B square equals to AC, which implies B square equals to AC this term. B square, which is equals to AC, right? So now, if A square plus B square comma AB plus of BC and B square plus C square are in GP, then AB plus BC whole square, which is equals to A square plus B square plus B square plus C square, right? So now LHS, which is equals to AB plus BC whole square, which is equals to B square is common outside, means what we get inside, A plus C whole square, which is equals to B square value is AC and A plus C whole square. Take it as equation 1. So now from RHS, which is equals to A square plus B square A square plus B square into B square plus C square, right? So here A square as it is, B square means again we know value AC, again B square is AC plus of C square, right? So by taking A common here, what we get inside, A plus of C into C common, A plus of C. So AC is common here into A plus of C whole square, right? So now take it as equation 2. From 1 and 2, LHS equals to RHS, hence the result. So this much is in this lecture series. In the next lecture we will study some more problems based on geometric progression, right? So till then, take care, stay at home, stay safe. Thank you.